सर क्लास स्टार्ट होने में टाइम है क्या अभी?
Hello, audible. Please make me host.
या ऑडिबल सर।
Yeah. Okay, so we cover up to here now at sixth question, please. Okay, audible, readable. Yes, please.
Yes, sir. Loud and clear.
Yeah. Please see this sixth question. Okay, here. This sixth. Compare the effectiveness of current limiting circuit breaker and HRC fuse. This is the comparison. Okay. So you know HRC fuse it is a detect and prevent. It is with this fuse wire only here. But in circuit breaker, your relay sense the fault, then trip coil is operate the breaker. Correct? There is a auxiliary circuit also there in with the circuit breaker. And this fuse wire is work on Joule seating I square RT. This is for short circuit only, but in breaker there is a short circuit under voltage earth fault protection also we can inbuilt. So you have to compare. It is available in this diesel ship notes. There is you can, and question answer file is there in the group. You can go through this. Now we come to this part B. A coil having, as I told na, in a solenoid coil. A coil means like this. Okay, this is the coil. So it has a resistance and inductance. Practical coil. Okay. What is the equivalent circuit of a coil? We can show the resistance, represent resistance, and coil inductance. Coil resistance, coil inductance. So this is the coil entire. This is the coil. This is the coil. Okay, this is a coil. Then in the series with this coil, there is a. So this coil has a resistance and inductance. It's connected in series with a capacitor. Now it is connected with a capacitor. So it make a RLC series circuit. Okay. this question is also based on your resonance circuit. Okay. So here this is the coil. Now value of this resistance is 10 ohm. This is 0.15 Henry, and this is C value is not given. Now here total applied voltage is this applied with a here voltage is 100 volt RMS value, frequency 50 hertz. Okay, so this is the total voltage, okay, across the circuit, 100 volt. Now this total voltage and the current here, current flowing through this circuit, okay, I. The phase difference between voltage and current are this, it will say that the voltage and current are in phase. Are in phase means phase difference is 0. So if your voltage and current V and I are in phase, it means phi equals to 0 degree. Then cos phi is unity. So means you can write here, since voltage and current are in phase, means circuit under resonance. So they form, it is a series resonance. Okay. RLC circuit when voltage and current are in phase means it is operating at unity power vector, and it is possible only under resonance. Now you write at resonance. What is the condition of resonance? Your inductive reactance is equals to capacitive reactance. So what is your XL? Omega L equals to 2 pi FL. So it is 2 into 3.14 into 50 into 0.15. Okay, 47.1 ohm. Correct? Same. Now, please, there is a this voltage across this VR, VL, and VC. But it is asking the voltage across coil, means up to here. Total coil. Okay. So what is the voltage across coil? Is this, suppose. Okay. So now we ask what is the value of current in the circuit, total current flowing through the circuit, and the voltage drop across the coil. Okay, now you can know. Then we can calculate total impedance. Total impedance under resonance, you know, impedance Z equals to R only, na? Or you can write here R square plus XL minus XC all square. Now these are equal, it means it is 0, then it is R only. So it is 10 ohm impedance. Therefore current I equals to V by Z. It is V by R only, means 100 by 10. It is 10 ampere. Current which is flowing through the circuit, it is 10 ampere. The first part is over. First part. Now they are asking VD, voltage drop, VD across or potential across coil. So there is a two method. Now you consider the circuit up to here. Here. So it is a series RL circuit. Now total voltage across, this is the voltage across R, VR. And voltage across L it is perpendicular to this VL. Then their vector sum. This will give you V coil, total voltage across coil. Okay. First, either you calculate VR, VL, then you calculate VC, V across coil. That is, it is a vector sum. Please do not add VR plus VL. Okay, it is not an algebraic sum. This is a vector sum. You calculate by this. Okay. Or there is another method. So now VR is VR is IR. VL is IXL. But now another method. You can calculate the coil impedance. Coil impedance. This impedance was circuit, total impedance of circuit. सर्किट का इम्पीडेंस अभी हम कॉइल इम्पीडेंस निकाल रहे हैं. तो कॉइल हैज ए रेजिस्टेंस एंड रिएक्टेंस है. कॉइल का इम्पीडेंस क्या होगा? ZC, इट इज R स्क्वायर प्लस XL स्क्वायर. योर 10 का स्क्वायर प्लस 47.1 होल स्क्वायर रूट. $48.149 ohm. Then this is the Z. Now VD across coil, that is V coil equals to IZ of coil. IZ voltage drop. So your current is 10 ampere. Z is 48.149. It comes 481.49 volt. Okay. Hello. See, we apply only 100 volt, but what is the voltage across coil? Almost 500 volt, 481 volt. So actually at resonance condition, magnification of voltage across L and C R take place. अभी अगर इसका हम बनाते हैं दोनों टोटल सर्किट का वोल्टेज, दिस फेजर डायग्राम, तो दिस इज योर करंट I. Now voltage across R is VR, this is VR. This is the voltage, ये दोनों के across ना, this is VL, this is VC. They are equal and opposite, but magnification take place. It is higher value. Okay, so total is 100 only as a result. But if we measure up to here, then it show. If we put the voltmeter, again we put the voltmeter across total circuit here, okay, then what value you get? 100 volt only. If we put a voltmeter here up to here, then what value you get? 481. Okay, correct. So this is the way. Clear? Or okay, so this question is okay. Clear? Next one is also very important, 2-3 times asked in your examination. seventh one. Okay. Describe the normal criteria used setting thermal protection relay. Thermal protection means it is bimetallic relay. We set for a overcurrent, and its advantage as compared to magnetic type relay. Okay. So your thermal relay, bimetallic relay, we use for overload protection. Okay. We compare with the electromagnetic relay. This so it is delayed operated. There is a percentage like 20% overload, 25% overload, like that. Okay. Now this there is a relay, but it is based on an inductance. You know the theory of inductor coil. Now low voltage release means low voltage coil of a AC motor starter, because you know in motor starter we use under voltage coil relay. That basically operate on induction, means magnetic effect. Okay, the plunger is pushed, then the contactor is NONC, then they operate. Okay, so here I will show you first. This is you know rigid on the spring. There is a one spring, suppose like this. Then this is the plunger, iron plunger, soft iron core. Now it is pushed inside the coil. Okay, this is portion one. In second position, now when it is pull inside, then it is partially in. When it is full in position, if soft iron core full in inside the coil, full in position, pushed in. Now these two cases are there, and they are applied with a AC source. Okay, this. Now we draw the equivalent circuit of this coil. So here is in first condition. Suppose here it is a I1 current. Here it is I2. Current will change. Okay. Now because here current is I1, then here flux. Hello, here magnetic flux. Okay. Here more flux will be there. More flux linkage. So here suppose phi 2. Here phi 1 flux. Okay, magnetizing flux. Correct? So here this current, if we remove the core, it draw the more current. So here current is high, flux is less still. But when we use a soft iron core inside the core, okay, then more flux linkage and current is also less. Means it draw the less current and more flux is there if core is inside. Okay. Now the equivalent circuit of this coil is, this is the resistance of coil, this is the inductance of coil. This is the resistance. Now resistance is fixed, it not change, but inductance is change. Okay, L, this is L2, this is L1. But here R is fixed of coil. So now it is RLC series circuit, okay, in both cases. Their impedance are different. Correct, current are different. Here it is I1, here it is I2. Okay, impedance Z2. Here I2 equals to V by Z2. Here I1 equals to V by Z1. Correct? Now let us, what is the values they are given? The resistance of solenoid. This coil resistance is 35 ohm. It is fixed, 35 ohm. When it is connected to, now voltage here 220 volt RMS value. It is RMS value. Then current is also RMS. P equals to 220 volt RMS. It is by default always RMS values are mentioned. Okay, please 50 hertz. Same here 220 volt 50 hertz. Okay. Now current taken at first initial condition. What is the current? 2 ampere. Initial. When the plunger drawn into the full in position, the current is down. Now if plunger is full in position, then current is down to, what is the current here? 0.7 ampere. इसको कहाँ लिखेंगे? मैं लिखते हैं 0.7 ampere. Okay, it's down. Part A, partial in position. This is full in position. B, full in position. Plunger is full in position and partially in position. Okay, two condition. If currents are given, then we can calculate their impedance. Z1 equals to V by I1 220 by 2, 110 ohm. Here Z2 equals to V by I2. It is 220 by 0.7. So now we calculate the circuit total impedance of coil. Okay, in both cases. It comes 14.38 ohm. Now R we know. So you know impedance equation is Z1 square equals to R square plus XL1 का square. यहाँ पर Z2 square equals to R square plus XL2 whole square. XL, so here L1, L2 ना. So what is the XL? We can calculate their XL1 reactance. Hello, this is reactance of coil. Here also reactance. So XL2 equals to Z2 square minus R square root. Here also Z1 square minus R square. Please 110 square minus 10 35 square, correct? Root. And this is this is 314.28 whole square minus 35 square. Please, this is square minus 35 square root. It is 312.33 ohm. This is 0 square minus 35 square root answer 104.28 ohm. So now this is your reactance. But he asked, so what they ask? React. It is not ask reactance, they ask inductance. Hello? Calculate the inductance of solenoid in both position. Partial in position and full in position. Now you know reactance. You know reactance equals to XL1, reactance equals to omega L, na? XL equals to omega L, you know. So now we, it is 2 pi FL 1, then now we ask L1, inductance of solenoid. L1 equals to XL1 by omega means 2 pi F. So my dear, this 104.28 divided by 2 into 3.14 into 50. This much Henry. For here also L2 equals to inductance and coil. That is XL2 by omega, again 2 pi F, or it is 3 divided by 2 into 3.14 into 50. Please. ये फर्स्ट पार्ट है 104 डिवाइड बाई 2 into 3.14 into 50. ये है आपका 0.332 हेनरी. Okay. So either L2 is 312.3 divided by 2 into 3.2. This comes 0.9946 Henry. Okay, clear? First part is over, huh? Okay, so let us now come to the question part. Now first part is over. They ask the inductance. Now next part, and maximum value of flux linkage, not leakage, it is linking in Weber turn. Unit is Weber turn. Full in position मीन्स सेकंड जो केस है उसमें आपको निकालना है फ्लक्स लिंकेज. So as in our last lecture, I told what is the inductance definition. Hello, mathematically, how we define the inductance? You know, inductance is nothing but it is psi by I. Psi is the total flux linkage by per unit current. Okay. So my dear, this psi is n phi, but it is second in position. It is phi 2 by I2. Phi 2 by I2. L2. Okay. So now he asks, this is the flux linkage. Phi n to phi 2 equals to L2 I2. Okay, dear? L2 I2. Because phi 2 equals to means it is a psi 2. Maximum flux. This is the formula, it comes from here only. Now n into flux means n is the turn, phi is Weber, so Weber turn. We read like ampere turn, Ni. What is the unit of Ni? Ampere turn. Similarly, n phi we assume as a Weber turn. Weber turns. Okay, unit. Clear? Now, but it is asking maximum. This is, here current value is RMS value. This current value is RMS value. Now, maximum. Therefore, maximum value of flux linkage in this position. So it is psi to maximum. Then n is fixed number of turns in coil. But your phi 2 we take a maximum value. So how we calculate? Now here is L2 is fixed value. But I2 we take a maximum. Now if you know the RMS value, what is the RMS value of current? RMS value equals to I max by root 2. Then I maximum is root 2 into RMS. Okay. So if you know the RMS value, very simple. Here just it is very simple. L2 you know what is value? It is 9.9946. Okay, 46 into current, but RMS value 0.7. So you just now insist of this. Now we write L2 into 2 root I2. I2 is your RMS value. So this is root 2 into 0.7. Root 2 into 0.7. This will give you maximum value and root 2. This is your peak value of this. So please 99 into root 2 into 0.7. It comes 0.9845 Weber turn. Okay. Maximum flux linkage. Okay. Easy? Any doubt? Hello, if you now inductance, up to inductance it is easy. Just impedance, then you know the resistance. This is the basic of RL series circuit. First you calculate Z, then XL, then L. When you calculate L, then flux linkage we can calculate in only in one case, not here. They are asking on second case only. Okay. This question was asked 3 times in your exams recently. Any doubt here? Yes, please. Now this here actually it is 8th, no? Yeah, 8, and this is 9. This question, here you write, 3-phase polyphase, it is polyphase connection, star delta connection. How we can connect either a balanced 3-phase, 3-phase star connection, and the second is balance. Balance means per phase values are 3-phase delta connection. Now write the basic equation. Actually, they are asking only the relation in voltage and current, but it is 6 marks question. But people are also write here this star delta conversion equation. Okay, thus they ask only the basic equation from which the star delta conversion equation are derived. You draw the, like star connection. Here 3-phase, now this is suppose 3 lines, no? Line 1, line 2, line 3. The voltage between 2 lines are called line voltage. And current through line, it is called line current. But current through this phases, no? Okay, this phase, that is called phase current. And voltage across this star point across the each winding, each phase, that is called phase voltage. And between 2 phases or line, that is called line voltage. So here relation in balance star connection, line voltage equals to √3 times of phase voltage. And here but line current equals to phase current. Here voltage, here this L, and voltage bit across this, this is phase voltage. But current here it is line current. Now at this, it is divided. Here. This is the phase current. So actually in delta, your line voltage equals to phase voltage. But line current equals to √3 times of phase current. This only. Now one is the battery circuit numericals. It was also asked in your examination 8B. Here he said that there are three batteries: battery A, battery B, battery C. Now you know battery equivalent circuit, their battery resistance and EMF. I'm like battery internal resistance and their EMF. Same like here battery resistance and battery. You draw the three batteries. Here now in this question the circuit diagram is very important. Okay, so this is the battery, three batteries. Sometimes we draw na battery is like this. So this resistance in series, you can say like this. Okay, this is the equivalent circuit of a battery. Yeah? Now we say that these are the positive terminals, positive, positive, positive. This is positive, and these are negative, negative of battery, negative. So their negative are short. But between positive terminal of A and B there is a resistance, and between B and C there is another resistance. So he said that their negative are connected together, and between the positive terminal A and B there is a resistance of 0.5 ohm, and this is point B and C there is a resistance of 0.3 ohm. And this battery detail A has a potential is, what is the potential of this battery? Is 100 volt. This has a no, it is 105, no? 105 volt. This 100 volt, and this is 95 volt. The resistance, this is 0.25. This is 0.2. This is point again 25 ohm. So now this circuit will be formed. Now we ask what is the current flowing through these two resistance. Yeah, Joanne. Okay, the resistance current is here. So this is R1 resistance, this is R2 resistance. Current, we can say this loop current is flowing here. Loop. Let us loop 1, loop mesh analysis. So here is suppose I1 current, here is I2. So here it is I1 current is flow through this resistance, here I2 is flow through this resistance. So by loop analysis we calculate I1, I2. After calculating I1, I2, they are asking determine the current and in the two resistance, then power dissipated. If you calculate current I1, I2, then power dissipated we calculate no P1, P2. It is I1 square R1. This is I2 square R2. Okay, easy. So by KVL you can solve. Applying Kirchhoff's voltage law in loop 1. First loop, suppose here loop 1, this is loop 2. Okay. So in first loop, we apply the KVL. Now if you write the KVL equation, so always across source, negative to positive. Always we write the equation, we move in direction of current. So current is flowing here. So from across this now, it is negative to positive means positive voltage. Then drop in resistance, na, it is current into resistance. So this both are coming in series. Either you write together or independent. So they drop here and here. It is always drop is negative. तो इकट्ठा लिख देते हैं, ये दोनों रेजिस्टेंस ऐड हो जाएंगे ना, बिकॉज बोथ आर इन सीरीज ना. ओके, दिस इनटू I1 into this, I1 into माइनस माइनस में दोनों. ओके, नेगेटिव, ऑलवेज ड्रॉप इन नेगेटिव. एक्चुअली आई राइट इन टुगेदर, या आप इनको इंडिविजुअल लिख सकते हैं. ओके, नॉट इशू ऐसा. ड्रॉप इन फर्स्ट रेजिस्टेंस, इट इज this much I1, then again it is 0.5 I1. Okay, now okay, then now we come to here. First we complete this loop. Okay, but now 0.2 ohm resistance, there is a two current, one is downward, other is upward. So we are moving in I1 direction. So we take here differential current, but drop is always negative. Okay, so here first resistance into current we take I1 minus I2, because we are in I1 direction, that's why I1 minus I2 we write differential current. Okay, then this voltage is negative to positive to negative, negative. ये आपका फर्स्ट लूप. ओके, 0. नाउ वी सिंप्लीफाई ना, तो ये सारे माइनस में ना, -0.25 I1 -0.5 I1 -0.2 I1 plus 0.2 I2 equals to -105 plus 100. ये उधर प्लस होगा, दिस इज माइनस. नाउ 1 2 3, ये 70.25, ये तीनों ऐड हो जाएंगे. ओके, दिस प्लस दिस प्लस दिस, 3 0.25 plus 0.5 plus 0.2, 0.95, 0.95 I1 plus plus 0.2 I2, and then it is -5. Here this is 1. Next, time KVL in loop 2. Now same way we write the equation for loop 2. So here you can start from any point related here. Negative again 100 plus. Then here there is a two current again, but now we are in I2 direction. So please you write I2 minus I1. Okay, here is only twisting. Then again in this two resistance there is a only single current, I2 only. तो आप ये इकट्ठा भी लिख सकते हैं. अभी 0.3 I2 minus 0.25 I2, then minus 95 equals to 0. Now please minus 0.2 I2 plus 0.2 I1 minus 0.3 I2 minus 0.25 I2 equals to 95 minus 100. I1 is 0.2 I1 and minus में this minus this minus this total है 0.2 plus 0.3 plus 0.25 0.75 0.75 I2. Okay, in this I1 I2 के form में लिखेंगे. Okay, then you write minus 5. Now this two equation you get. Okay, so by solving these two equations, above simultaneous equations, I1 and I2. I say solving this equation I1 I2, you get a I1 and I2. See, there is you can use the calculator to solve this equation. You go to equation in two unknown. Okay, so you write minus 0.95 then 0.2 minus 5. Next equation is 0.2 minus 0.75 minus 5. You get a 7.063 ampere. Second, you get a 8.55 ampere. These are the two currents. Okay. So this is the current through R1. Current through 0.5 ohm. This is current through 0.3 ohm resistor. Okay. R1, R2. Now power dissipated. P1 is I1 square R1. P2 I2 square R2. Is 7.03 square 2.5 8.55 square into 0.3. Yes, please. Seven point zero six three square 5. This becomes 24.95 94 only. Then 8.55 square into 0.3 21. Any doubt here? Hello? Here you have to draw the circuit. Okay? Audible?
Yes, sir.
Next, next question is based on actually your rectifier. Okay, so here it is need to you to know the knowledge of rectifier. Okay, and AC fundamental. what is the values, peak value, RMS value, form factor, peak factor. Okay. First of all, we explain these things, then we explain the rectifier also, because there is a question also from rectifier circuit. Here we take a break 5 minutes, then we will actually here the explanation is required in this ninth question. Okay. This we can directly solve, but when we explain, you can solve the rectifier question, other question also. Okay. And there is a one question also, some they ask, what is the significance of RMS value, peak factor? This question was also asked in theory. Okay. I will show you the question. Yes, explain the significance root mean square value of alternating voltage and current. Define the form factors. Okay. Here, these old questions of ETO, these are easy, and you can solve this question. Okay. Yeah, already हमने solve किया है. So here we take a 5 minutes break, then we start. Okay. Please do not leave the meeting. Hello, audible?
Yes, sir.
Hmm. So first of all, AC fundamental, just I brief you. I will cover this also, significance of RMS value, what is the form factor, peak factor, okay? So first of all, AC. AC means alternating voltage and current, or sinusoidal voltage and current waveform. So you have to draw. Nine ना ऐसे और part है part है क्या it is terms see here is also asked this what is the terms of waveform, frequency, average value, RMS value, peak value, okay, and then significance of RMS value. So see here, we draw the voltage and current waveform. So this is the means when we represent a value, okay, with respect to time, the variation of a quantity with respect to time is represent, it is show a waveform, okay. So this is the voltage waveform, let us voltage with respect to time. Now this is a 0, then time in pi, this is 2 pi, okay, angle of time. Now it is appear at a peak value here. Now this one cycle is consist of a positive and negative half cycle. This is called one cycle. Cycle, okay. And time taken to complete this one cycle, it is called time period T. Okay. Then frequency. See, it is 1 by T, time period. Means per unit time, how many cycles completed. So it is cycle per second, or it is called hertz. Okay. So 1 by T, it is cycle per second or hertz. This is the frequency. Now waveform frequency. Now we come to the values. If we talk about the values, so here this because alternating current and voltage it is vary. So there is at a different time like T1, T2, T3. These values are like V1, V2, V3. This is called instantaneous value. And the maximum value attained by a voltage or current, that is called a peak value or maximum value Vm. Now if we calculate their average of complete cycle from 0 to 2 pi, so actually this will give the average. Now we can calculate, maybe their average is come here like this average value. So this is called V average. then their RMS. So three values are defined. Instantaneous value, then peak value, peak, or it is maximum peak value. This is represented by VM. This is like V1, V2. Okay. Then you got average. Average value. Okay. V average. Then RMS. VRMS. Okay. So here this we know. Now we average. Now average means under the curve. Okay, we calculate this value. So if we know the equation, or either you add this all V1, V2, V3 divided by T1, T2, T3. Okay, or there is another. You know this have a equation V equals to Vm sin omega t. Then if we integrate average, how we calculate average value? Very simple. V average equals to integrate from 0 to pi. If you integrate from 0 to 2 pi, it get a 0 because it is positive negative. So first we integrate 0 to pi, then double it, double of V d omega t, then divide by t, time period. This will give average. Then so see 2 by t, now integration 0 to pi is Vm sin omega t d omega t. Okay. So this Vm we take outside, Vm by t, it is 2. Then Vm is constant. Now sin it is minus cos omega t. Then you put 0 to pi. Okay. And t is the 2 pi. Value of t is 2 pi. Here 2 say 2 cancel, and here now you put the limit, it comes minus 2. Minus 2. Okay. Sorry. It comes plus 2. So this value will become 2 Vm by pi. So what is the average value of AC? 2 Vm by pi. Okay. This is the average value of this for this type of sinusoidal waveform. This is the average value. Same like if we calculate RMS value, this is average. Now RMS, VRMS. So it is square means we do the square. Then mean means average. Again you calculate average value. The average is this, no? Sorry. By T, d omega t. Then okay, square, then mean, then root, like this. So again you put the value, you calculate, now we get we get Vm by root 2. What is the RMS value of AC? Please remember this two well. Okay, this is the RMS value and this is average value. And peak value, you know. Now there is a two, sometimes there is peak factor and there's two values of peak factor and from factor. Peak factor, not power factor, it is peak factor. Okay, form factor is RMS value by average value, and peak factor is peak value by RMS value. Peak is VM by, now RMS value is VM by root 2. Okay. So now VM cancel. So it is root 2 only. And what is the value of root 2? 1.414. क्या होती है बताइए? रूट 2 1.414. Okay. Then this form factor is RMS value is VM by root 2, and this average value is 2VM by pi. So now VM by root 2, now we multiply, we convert into multiplication, then it is inverse, na, pi by 2 VM. VM cancel, so it become pi by 2 root 2. 3.14 divided by 2 into root 2 means 1.414. 1.414 into 2. 1.11. Okay. So for sinusoidal voltage or current, form factor is 1.11. That's why this AC voltage are multiple of 1.11, like 11 kV, 33, 6.6, 220, 110, as are like that. Okay. Clear? Now come to next part. If we saw the rectifier, rectifier circuit, we apply the AC. In rectifier circuit, actually first is your AC source. Then to prevent, to get a desired voltage and we protect from internal, spike, we have a isolation transformer. What is the purpose of this transformer, input transformer? Hello? There is a two purpose. Suppose it is a 230 volt, 240 volt AC single phase. So only we get a 110 volt here or 210, 220 volt. That's why we have a transformer. Second, it protect from your external voltage surge. It is called isolation transformer. If there is a switching voltage surge is there, so it isolate your electronic, means your diode circuit. Like these are the diode. If high voltage has come, they can be damaged. So it will prevent. So now this is the diode, and then we have a load resistance here. Okay, this across this load resistance we get output voltage. It is a DC output because after diode. Before diode, here is also AC. Here also AC. Okay. Here you get a DC. Here is also, now it is a source voltage here. And this is source current, input current, and output current, load current. So actually current are same because it is a series circuit, but output voltage we measure across load resistor, and this is your input voltage is AC. Okay, this is also. तो हम इसकी बात नहीं करते हैं. We have only this much diagram. Okay, so here is your input voltage. Generally यहाँ पे दिया रहता है voltage. Okay, and that is given, if not mentioned means it is a RMS value is given always. Here this voltage is given RMS value of this AC, this diode and resistor. Okay, so this is your source voltage. This represents the source voltage. Current is flow. I will draw here circuit. Hello, here we show the source means input voltage. It is sinusoidal like this. Now here. So see, here is we show the output voltage. Now when forward, okay, positive pulse come na, this input voltage positive pulse. This diode is forward bias, it conducts. So suppose this diode resistance is there forward, but sometimes it is ideal diode has a zero resistance, so no drop here. Entire as it is we get here in output. Okay, same pulse without drop. So this is the voltage across after diode input. This. The negative, then it is reverse bias, it not conduct. Then positive pulse come, then it is half wave rectifier. Okay. Okay, so this peak value, na, same peak value we okay, this. Hello, now I clear. This is not a pure DC. This output voltage is a pulsating DC. So it also has a peak value. We can also calculate their its average value. Average value is like this. Up to here it is 0, pi, 2 pi. So this gives the average value. Now this average value we have a DC. It is called DC value. And we can also calculate RMS value of this output voltage. RMS value, it is called AC value. Okay, VAC. Okay, clear? AC value. So DC value is average value of output voltage. RMS value of output voltage value is AC value. It is called. Okay. तो ये आउटपुट के लिए भी हम ये वैल्यू निकाल सकते हैं बिकॉज इट इज नॉट ए प्योर डी. ओके, क्लियर? I tell you, half wave rectifier and full wave. Full wave में we get a both cycle. So for half wave value, now I write here. So their peak values you know, but now we get their average value. Average value of output voltage means it is VA or DC value, it is called DC. And RMS value of output. हम ये output voltage के लिए बात कर रहे हैं. Okay, for half wave rectifier output, it is AC. It is represented by AC value, okay, VS और IS है, करंट है तो करंट का रहेगा, VDC VSC. Now for half wave it is average value. What is the average value for half wave? So half wave, if we again we calculate like from 0 to pi, then total time period is 2 pi. Okay, 0 to pi, half cycle है. We cannot double because here it is not there 0 na. So it is here we write again this equation also same na, Vm sin omega t d omega t. So if we calculate, we get a Vm by pi. Please, for half wave rectifier output Vm by pi, and for full wave it is again same like a AC value na, 2 Vm by pi. It is double for full wave because this here also we get a pulse in full wave. Okay, that's why it is double. Now AC value RMS value जो हम निकालते हैं इस केस में, तो it is Vm by और Im by 2, not root 2. Same like I current के लिए भी होगा ये 2. Okay, अगर हम करंट की बात करेंगे है ना, ये तो वोल्टेज हो गया. करंट में हम IDC लिखेंगे और VDC है, that is average value, it is Im by pi. Okay, करंट के लिए. एंड AC करंट होगी जो वो होगी Im by 2. ये वोल्टेज और करंट है, तो ये 2. ओके, नाउ फॉर फुल वेव. फुल वेव के लिए हम करंट को लिख रहे हैं, करंट की जरूरत होती है हमें. तो यहाँ पर क्या होगा IDC, इसके लिए डबल हो जाएगा 2 Im by pi. एंड IAC it is Im by root 2 like a full in full wave. So please do not confuse. For half wave it is this. For full wave it is this. Okay, clear? Now this is the voltage. Now current waveform you can also show. तो यहाँ पर हम करंट अगर दिखाते हैं ओमेगा टी, तो देखिए नाउ व्हेन करंट इज, आप ऐसा निकाल सकते हैं ना, ये वो व्हाट इज द करंट इज. इफ यू नो द वोल्टेज देन I नॉट इक्वल्स टू V नॉट बाई RL और VDC suppose equals to IDC to RL. ड्रॉप ना हियर, तो यहाँ पर ये करंट हो जाएगा, दैट इज आल्सो लाइक I नॉट और IDC सेम लाइक दिस. ओके, प्लीज IDC means VDC by RL. Okay, VDC by RL. That is, now we come to the question. Now you know instruments we have a like moving PMMC type and thermal type and rectifier type. Okay, so now there is a emitter has a moving coil emitter and thermal emitter and a rectifier. एक rectifier means diode है, वो connect किया है. Then in series with this there is a 2 emitter we have connect different type, A1 A2. Okay, यहाँ पर आपने AC वोल्टेज अप्लाई किया, वो RMS वैल्यू इधर नहीं भी दिया है ना, इट कनेक्टेड इन सीरीज विद 110 साइनसोइडल सप्लाई. तो ये ऑलवेज ना RMS वैल्यू ही मेंशन होता है. ओके, दैट इज द सिग्निफिकेंस. ओके, इन RMS वैल्यू. then there is a total resistance here to the circuit. Is consider all the meters and this. Suppose they have an ideal instrument, no resistance. It has a zero resistance in forward, and in reverse bias, it has an infinite resistance. So no reverse current will flow. Okay. So here current is flowing like this way. So here it is 110 volt. Then the current is flow through this, and here output current, and across this load resistance it is given 50 ohm. The resistance is this in one direction, in forward direction, infinite in other direction. Reverse में current flow नहीं होगी. Okay. So this is the voltage across this VD or V out. Now we calculate the diode. This is PMMC type instrument, and this is thermal type emitter. Okay. Now you know this is measure the DC value. ये DC measure value को measure करेगा. DC value means average value. And thermal वाला है जो RMS value, root mean square value को measure, RMS value measure. Okay. Thermal is your heating. Okay. Effect. So first we calculate here reading of emitters A1 A2, and then form factor and peak factor of this current waveform. पहले निकालते हैं हम RMS value of source supply voltage or source voltage. हम RMS value दिया है हमें. Okay. 100 volt. Therefore we calculate their peak value or maximum value. √2 into VRMS. कितना होगा? √2 into 110. Peak value we have calculated. .555 volt. Okay. Now what is the maximum value, peak value of voltage is 155.56 volt. यहाँ पे apply हुआ. If you know the total resistance of this circuit is 50 ohm, then we can calculate therefore. अभी जो करंट तो सेम होगा इनपुट साइड या आउटपुट साइड है, then we can calculate ना. Therefore current तो ये peak value आएगा पहले. Okay. If you take a peak value of voltage, then we can calculate peak value of current of load current or flowing through the circuit of load current or flowing through the circuit. So it is IM equals to VM by total resistance. Sometime ना डायोड का रेजिस्टेंस रहता है तो हम डायोड का रेजिस्टेंस भी ऐड कर लें, बट यहाँ पे नहीं दिया है. ओके. Total resistance is included here RL. It is 155.56 divided by 50. यहाँ पर कितना आ गया? Divide by 50. 3.11 ampere. A peak value. This is the peak value of current. Please. Now we can calculate average value of this current. Average value. Average value. Average value means it is DC value. Okay. And this is I of current. So for half wave, as I told, it is Im by pi only. Im is 3.11 divided by pi means 3.14. हो गया 0.99. Then we calculate RMS value of current. ये है एवरेज वैल्यू, इसको हम आई एवरेज भी लिखेंगे. एवरेज एनवी ऑफ करंट विच इज आई. इसको ऐसी भी डिनोट करते हैं और ये आई आर एम एस भी होगी. ओके. तो ये क्या होगा फॉर रेक्टिफायर है. इट इज हाफ वे फॉर आई एम बाई 2 ओनली. प्लीज डिवाइड बाई 2. ये हम आउटपुट करंट की बात कर रहे हैं. ओके. नॉट फॉर साइनसॉइडल दिस. और इसको या फिर हम शॉर्ट में लिख सकते हैं 5-6. ओके. तो ये तीनों वैल्यू हो गई. पीक वैल्यू, एवरेज वैल्यू, आरएमएस वैल्यू. अभी वो क्या पूछ रहे हैं तो देखिए आपका कौन सा मीटर है. ये है ना जो A1 PMMC टाइप है. इट रीड DC वैल्यू. तो विच इज द DC वैल्यू? एवरेज वैल्यू. ओके. So what is the reading? Emitter A1 reading. A1 reading. Emitter reading. A2 emitter reading. It read DC value, average value. That is 0.99 ampere. This read I square R ना, it is heating, joules heating law. तो heating के लिए हम ये यूज करते हैं ना RMS value, रूट मीन स्क्वायर. It read 1.56 ampere. This is the reading है. ये फर्स्ट पार्ट हो गया आपका. Second part they ask their form factor and peak factor. What is the form factor and peak factor for this current? फॉर्म फैक्टर के लिए हमने क्या फॉर्मूला बताया था. पीक के लिए पीक वैल्यू बाय आरएमएस वैल्यू. आरएमएस ना आई आर एम. आउटपुट वेव फॉर्म के लिए है. प्लीज नॉट फॉर इनपुट. अभी अगर ये इनपुट की साइड में ना यहाँ पर जो वोल्टेज है उसकी तो आरएमएस वैल्यू, पीक वैल्यू, एवरेज वैल्यू ये वाली होंगी जो हमने एसी के लिए निकाला, क्योंकि इनपुट साइड में आपकी साइनसॉइडल वेव है. बट ये आस्किंग था फॉर आउटपुट साइड. यहाँ पे जो आउटपुट है इसके लिए जो आरएमएस वैल्यू ये वाली होंगी, एवरेज वैल्यू, आरएमएस वैल्यू. ओके. तो यहाँ पर अभी ये 1.11 नहीं होगा. ओके. इफ यू पीक है, ये पीक फैक्टर, पीक वैल्यू भाई आरएमएस वैल्यू. तो व्हाट इज द पीक? पीक वाज हमने निकाला था ना, क्या आया था पीक वैल्यू. पीक है आपका 3.11. 3.11 divided by RMS value is 1.56. फॉर्म फैक्टर में इट इज RMS वैल्यू बाय व्हाट इज द फॉर्म फैक्टर पीक फैक्टर फॉर्म फैक्टर यार peak value by RMS value is the peak factor and RMS by average RMS by average RMS by average by average तो ये होगा I RMS by I average in DC तो ये RMS I ये these are the questions हैं प्लीज बीच में एक और भी है वो पैरेलल रेजोनेंस का भी क्वेश्चन आया अब यू गो थ्रू द क्वेश्चन पेपर है प्लीज 1.576 and 1.998 okay 1.99 you can write okay good night please okay how was the lecture hello 2 days class
गुड सर गुड सर 17 को पेपर है तो सर उसके पहले कवर हो सकता है क्या सर मैसेज?
हाँ करा देंगे सब है ये फर्स्ट चैप्टर हो गया कल DC मशीन करा देंगे
ओके थैंक यू सर।
आप करते रहिए साथ में हाँ